Sequences. This is actually my favorite question of the whole paper, and I mean it. This is really nice. If you guys have sequences in your exam, call it a blessing because it's really good. But anyway, let's have a look at the question. So we got a sequence which is A1, A2, A3 is defined by the given ones, where A1 is 4 and every next sequence after is defined as the previous term over the previous term plus 1. So when I say that an plus 1 and an, this is simply the next term up after an. So to find a2, you plug in a1 results. To find a3, you plug in a2 results. To find a20, you plug in a19 results. So it's always the next sequence up. Now let's look at this. A. Find the values of a2, 3, and 4. Okay. Now this was really straightforward, and I don't know why I left answers there. All you do really, to find a2, you plug in a1 results. So it's going to be 4 over 4 plus 1, so 4 over 5, and that's, well, 4/5. To find a3, you plug in a2 results. So you can use answer a2 into the formula, so it'll be 4/5 over 4/5 plus 1. And when you tidy this up, there's a really nice way. When you got fractions in a fraction, you want to try and clear the fractions inside it. So because they're both over 5, I times up and down by 5. Because it's like times by 1, it has no effect. When you do that, 4/5 times 5, they cancel out the 5, so you're left with 4. When you times the bottom by 5s, 4/5 and 5's cancel out, you're left with 4. And then 1 times 5 is 5. And then you're left with 4 over 9 when you tie this up. Easy. As for A4, you just use your A3 results and then copy what we did. Because now you got 4 9s over 4 9s plus 1. You want to times up and down by 9 to clear out the 9s. And doing so, top half becomes 4. And bottom half, this first term becomes a 4. And times into this by 9, you get a 9. And then tidying this up, you get 4 over 13. That's it. Not bad. Man. This is why, sometimes they're tricky, but you just have to really be careful when you simplify. But like I said, when you got fractions on fractions, always try and clear the fractions first before you do anything else. Okay? Alright, let's look at the next bit. So given that you got an equals 4 over pn plus q, so this looks like they're trying to make a general nth term now. State the value of p and q. Okay. So this is just pure observation skills. You'll realize that there's a 4 on the top. And when you look at our working outs, we always had a 4 after we did some kind of techniques, times them by 5s or 9s. So one thing you can kind of observe from here, like just looking at head on, if they both go 4, this means that the bottom half must be equivalent to this expression at some n value. So what I'm trying to say here, like let's look at a2. You can say that when n is 2, we can have basically p times 2, so 2p plus q is going to equal the bottom half, which is 4 plus 1, which is 5. So 2p plus q equals 5. So what I thought, you know what, let's match each term. So at a2, we can say that the bottom half of a fraction here, when n is 2, we get 2p plus q, and this is equivalent to the bottom half of our solution, 5. For a3, when n is 3, we're going to have 3p plus q, and this is going to be equal to the bottom half of our a3 solution, which is 9. That's it. You could do the same for a4, but it's just nice to have like a general pattern. Now, what they want you to do here, which is quite clever, is that you're going to use simultaneous equations now. So this is not obvious, but that's what they want you to do. You're going to simultaneously solve some of these. So what I did, and I used the first two, I subtracted a3 from a2. So look at these two equations here. So subtracting these two, you're going to get the q's cancel out, and you got 9 take away 5 is 4. 3p take away 2p is 1p or p, so that immediately gives us a result. And now because you got p equals 4, you can plug it to any equation. I plugged it back into the first equation because you got 2 times 4 is 8, and 8 plus q is 5. So q, solving it will give us minus 3. And that's it. Now part C is actually similar. It says, hence calculate the value of capital N such that a capital N equals 4 over 321. Again, you still got a 4 at the top, so you can say basically that wherever this solution is, Pn plus Q has to equal 321. That's the first step. But because we got P and Q already, we can put them back in. So we're going to have n times 4, so 4n minus 3 equals 321, if that was it. And then we could just solve it. So plusing 3 across, you get 324, and then dividing by 4, you get 81. Voila.